Alright, welcome once again. So now let's talk about working with timers. So when it comes to timers are used for delaying. Okay, you can either use it to delay an output coming on or use it to delay the turning off of an output. So it works in two different ways: turning on an output and delaying it in turning on an output. So when it comes to Siemens, there are four major types of timers we have here. We have our pulse timer, which you can find under your project 3. You see your S pulse timer, called your pulse timer. The S stands for semantic pulse timer, semantic extended extended pulse timer, SPEST. You have your on delay timer, SODT. Then you have your retentive on delay timer, ODTS, and you have your off delay timer. So you note one thing about these timers: these are not general PLC timers. These are semantic timers. They are used in Siemens. There are some timers we talk about IEC timers. The IEC timers are the timers that are general for all PLC. So I would say before the coming of, okay, let me just leave that part out for now. So there are just 5 timers here. Generally, there are just 3 types of timers in any PLC. You have your on delay timer, your off delay timer, and your retentive timers. But always take note, as I put it here, no NB, not better. Okay, your timers are 5. There are 5 timers that we have here: your pulse timer, extended, on delay, retentive. They are all semantic timers. If I go to Siemens, I won't see this. If I go to Schneider, Delta PLCs, Mitsubishi, name them, I won't see these timers here. I will see on delay, off delay, and retentive timer. So let's start from the first guy, on delay timer. Okay, so for our on delay timer, just talk about the timer block a little bit more. So in the timer block, you have your S and your R. Remember your set and reset, something like that. Okay, so you have your S and your R. Then you have your TV. Your TV is your time value. Your S is your set. Your TV is your time value. Your R is your reset. Okay, and you have your Q. Your Q is your output. I think I have to slow down a bit. Okay, your BI is your binary integer. Your BCD is binary code decimal. So the main things we'll be making use of here is your S, TV, your R, your Q, your BI. So for your TV, your time is always given in S5 time. How do you put in your time here? You call it S5T as 5 seconds. If I want to name my timer, I call it S5T at, if I need it for 5 seconds, F5X. If I need it for 10 seconds, 10X. If I need it for 20 seconds, 20X. Okay? So that is how I put my time for this TV. My set is going to be my start. My R is, maybe I want to stop before the time is concluded, and I make use of my R. So for my on delay timer, your on delay timer, on delay S5 timer, that is why your time value is given in S5. When it gets to come to your recent timers, your TIA timers, you don't get to see S5 written on them. Okay, they just write them as T at 20 seconds. So that is a discussion for another day. So for your on delay timer starts the specific timer if there is a positive edge at the start input. So for this timer to start, whatever coil we are putting here, maybe a sensor or a push button or a contact, whatever you are putting here must see a positive edge. When you talk about a positive edge, you are talking about a 1. A signal of 1 is actually a positive edge. So there must be a positive edge at 1. So the signal change is always necessary in order to enable the timer. Yet for your on delay, there must be a change from 0 to 1 before the timer will start. Okay? A change from 0 to 1. So a trigger from 0 to 1. And that 1 must be a continuous signal. So in this case, I can put start the specific timer if there is a what? If there is a continuous, let me just add that here. If there is a continuous positive edge at X. Okay? The signal change that we have mentioned that. So the timer runs for the time interval specified as the input TV, as long as the signal state at input S is positive. So for your timer, what is it trying to tell us? It's trying to tell you that if, for instance, I've given this 20 seconds in my TV, that for this timer to start in on delay, once I give it a continuous positive signal at S, it will wait for this TV time. Okay, it will wait for this specified time, that is 20 seconds, before the output would come on. So this set must see that input signal for 20 seconds before output would actually come on. So I put this in bold here. The signal state at output Q is 1, that is your Q is true, that is on or is running, when the time has elapsed and the signal state at S input is still 1. So this Q will only come on when the timer has elapsed, that is after 20 seconds, and the signal state at S is still 1. That is if the signal at S is still 1. If the signal at S is no more 1, it resets the timer and the Q goes off. So let's use this in our program. Let's go down and add a new network to this. Okay. So if we come to your project part, you can see your timers down here. So I'm starting with explaining the on delay timer. I bring this in. So the first thing I always need is to give it a timer address. The timer address is just that location where it stores that value. Just like when we worked with our set and reset, we had the memory value for it. So I'll just call this T1, cap block, T1, either capital letter or not, anything you use, T1. Okay. So what do I want to use to set this timer? I want to use I0 dot, I don't know which time context I've used before, but let me use I 3.5. Okay, to start this. Next, it will ask you for your TV, that is your time value. TV is time value. So, and it is written as S5T hash what? Let's say I want it to run for 20, 10 or 15 seconds. Let's say 15 seconds. 15S. Enter. So I've set that time value for 15 seconds. So what this means is going to delay for 15 seconds before turning on this output. And this output at this point, I'll call this Q0 dot Q3.0. I don't think I've used that. Just put there's no conflict. And just check that Q3.0. Okay, yeah, I've not used Q3.0, so I'm safe. Alright? So Q3.0. So what this means is that once I trigger 3.5, it will wait for 15 seconds before turning on Q3.0. So let's see that with the simulator. So let's save this, download this, yes, and let's monitor this. So you can see at this point 15 seconds. So once I click on I3.5, you can see the timer start counting down. Let me say timing down or delaying down, counting the time. Actually, I don't want to call it counter so we don't conflict it with counter. So it's the time is ticking. Then after the set time, that is when this output comes on. So for on delay, how does on delay work? Once there's a trigger at your S, the time value start timing down. The delay starts timing. It means the word timing. The delay starts timing and turns on that Q3.0. If I remove this signal at 3.5, it stops the timer automatically. So if I start this, it starts the timer. So it will not come on until that timer is done timing. So if I want to stop this prematurely, I'll just remove this time value. It stopped. And it was left with at least 5 seconds, 500 milliseconds to complete. If I trigger this once more, it will start all over again. It won't continue from there. It is not a retentive timer. It is just an on delay timer. So that's how your on delay timer works.